Chapter 6.4, Quick Review Exercise 1 through 10. Section 6.4 in the book has to do with using polar coordinates, and this quick review is a section, a set of exercises leading up to working with polar coordinates. And we're going to go over the odd number problems here. In exercise 1 and 2, determine the quadrants containing the terminal side of the angles. And we're given two angles, one 5 pi over 6 with a positive angle and a negative angle, negative 3 pi over 4. And for this, I'm going to go back to a unit depiction of the unit circle, which I'm drawing here. It's kind of a odd shaped circle. This is a bigger circle. Okay, I can live with this bigger circle. And we have an x coordinate and a y coordinate for this unit circle. And not too shapely, but we'll have to do today. And 5 pi over 6, well, that's going to be, now pi is over here at equivalent to 180 degrees, and 5 pi over 6 is going to be this angle right over here. So 5 pi over 6. And basically that's going to be quadrant 2. So there's quadrant 2 right here. So I'm going to say part A here, 5 pi over 6. I'll say quadrant 2. And 2 in Roman numeral style. And then we have part B, which is negative 3 pi over 4. Well, negative pi is going to be rotating this way, clockwise. And 3 pi over 4 is going to be, our negative 3 pi over 4 is going to be right here. And this here would be negative pi over 2 down at the bottom, and negative 3 pi over 4 would be right over here. Negative pi would be all the way back to equivalent to 180 degrees. So our answer to part B is going to be quadrant 3. And there it is, quadrant 3. So that's going to be problem number 1. And next on our problem 3, in exercise 3 through 6, find a positive and a negative angle coterminal with a given angle. Well, again, we're just going to put a little circle here. This one's a little smaller, quite a bit smaller. And we have the angle negative pi over 4. Well, positive pi over 4 is going to be right up here, equivalent to 45 degrees. And if we rotate instead of counterclockwise, we will have negative pi over 4 down here. And we want to find a positive and a negative angle coterminal with a given angle. Well, coterminal means ending in the same place. So to give a positive version of the angle, I'm going to do this in blue. We're going to have to come all the way around here. And 8 pi over 4 would be equivalent to 2 pi, and this is pi over 4 less. And so an angle would be 7 pi over 4. So that would be our positive angle. Now for our negative angle, what we're going to do is we're going to go around clockwise in red, and we go all the way to I'm going to go from here, clockwise, and then another pi over 4. So we're going to have negative 8 pi over 4 minus another pi over 4 And so that's going to be negative 9 pi over 4. That's going to be another angle that's coterminal with negative pi over 4. So we have a negative angle and a positive angle, and these would be, there's an infinite number of angles really, but these are kind of the closest ones I could find. Next on our problem, which is 5, again, find a positive and negative angle coterminal with a given angle. This time we're given degrees and not radians. And really, for understanding of the common person, including myself, I'm much more familiar working with angles than I am radians, just kind of on a day-to-day basis. But I'm going to draw a quick unit circle here with an x and a y coordinate. Okay, and we have 160 degrees. Well, 160 degrees is going to be just 20 degrees short of 180 degrees. So this radius, this ray that I'm drawing in blue, is pretty close to 160 degrees, we'll say. And we're going to get a positive and negative angle. Well, to get a positive angle, I'm going to continue in blue. We're going to go to 160, and then we're going to wrap around another how many degrees to get back to a coterminal angle? Well, another 360 degrees. So one answer is going to be 160 plus that other next rotation of 360 degrees. And so just kind of lining up, looks like it's going to be, I'm not mistaken, 520 degrees. So that's going to be our positive angle, okay, that is coterminal with 160 degrees. Now for our negative angle, we're going to come and go instead clockwise. And here it is in red, coming clockwise. And this is a negative direction. So we went negative 180 degrees plus another negative 20 degrees. So we're going to get negative 200 degrees. Is that right? Yeah, I think that's right. So these would be our two angles, one positive and one negative. Next problem we're going to look at is exercise 7 and 8, write a standard form equation for the circle. Well, we have to know what the standard form equation is, and it's simply this. That's going to be quantity x minus h squared plus quantity y minus k squared equals r squared. So if we have a center of a circle, I'm just going to draw a quick sketch of this circle, and we have an xy coordinate plane, and we have a center of 3, 0, and so there it is, the center of 3, 0, and a radius of 2. So this is what our circle would look like. Just shifted right. And what we're doing is that the circle shifts to the right if h is a positive number. And so what we're going to have, our equation is going to be x minus 3, and that minus 3 shifts that circle to the right 3 units squared, plus we have no y shift. The y value is 0. So we have plus y squared Because remember, in our standard form, y minus k is 0. Well, quantity y minus k squared, and y minus k has to be 0, so k has to be 0. And so we have equal r squared. Well, r is 2, so 2 squared is 4. So this is going to be our standard form equation for this particular circle. And if we wanted to solve for y, we could graph this out or use a graphic calculator with conic features in it. Next on our problem, which is 9. In exercise 9 and 10, use the law of cosines to find the measure of the third side of the triangle. Well, the law of cosines, and there are 3 different versions of the law of cosines. I like to use the version that is most analogous to the Pythagorean theorem, which is a squared plus b squared equals c squared. And that version is, we take c squared as in little c, and I'm going to label this triangle little c, the side that we're trying to find, because we have those other 2 sides, equals a squared plus b squared minus 2ab cosine of big C, angle C. So in this case, we're going to have c squared as in little c squared equals a squared. We'll say a is 10 and b is 12. So we'll say 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of what angle? 60 degrees. Now, what we really have is this last thing here, minus 2ab cosine c, is what adjusts for angles other than 90 degrees, because except for this minus 2 times ab cosine c, this is just the Pythagorean theorem. So this last thing just adjusts for angles other than 90 degrees. So we're going to have c squared equals, I'll just 100 plus 144 minus 2 times 10 times 12 times cosine of 60 degrees. And the last thing I'm going to do is take the square root of both sides of this equation. So we're going to have c is equal to square root of all this. So we'll have 100 plus 144 minus 2 times 10 times 12 times the cosine of 60 degrees. Okay, and going to our calculator, here's our calculator, and I'm going to go to take the square root of, we have 100 plus 144 minus 2 times 10 times 12 times the cosine, we go to that trig button, cosine of 60 degrees. So there we have about 11.14 rounded to the 100th place. So say right here, and so that's going to be our answer for problem number 9. Good luck on your even number problems. Good luck working with the graphing polar equations. Thanks for viewing.